Hi everyone, and welcome to our second video for the isosceles triangle theorem. This one is going over some practice problems. A lot of these are going to look familiar. I'm just doing the example ones we did in class on the pair deck. However, some of the classes had to skip one of these practice problem sets, and they were giving them a little trouble on the worksheet. So I'll go over the one that we skipped. So I would recommend watching this video and maybe skip into the one we went over, right? But the rest of them, I'm just reviewing on the example problems. So I invite you to watch this video if you need a review or additional assistance. But a lot of you, if you were able to follow along in class and you weren't asleep or struggling or whatever, should be a pretty clear-cut video. Okay, so let's check it out without further ado. The isosceles triangle theorem, check out the last video or your notebook if you wrote it down, right? You should have written in your notebook. Remember the isosceles triangle theorem is that if I have two congruent sides and their opposite angles are also congruent, or vice versa, if I have two congruent angles, their opposite sides are congruent, right? So in both of these example problems I have here, I have two congruent angles or two congruent sides. Using the isosceles theorem allows me to say that this is congruent to this. Opposite sides are congruent by the isosceles theorem. And over here, two sides that are congruent means the opposite angles are congruent. If I have sides that are congruent, that means x equals 11, right? And if I have angles that are congruent, that means x equals 27 degrees, right? Now, if I was to try to write this down as a justification, right, they said justify your reasoning, all you need to say is by the isosceles theorem. I don't need to repeat any information they've given me. A lot of people, when I ask how would you justify your work here, they try to walk me through the isosceles theorem, right? I don't need you to explain the isosceles theorem to me. We just went over it together, right? All mathematicians will know the isosceles theorem. And if they don't, they'll just look it up and they'll be able to follow along with the theorem and go, okay, this is always true, so I can follow along now when you do this, right? You don't need to tell me, well, the base angles are congruent, so the opposite sides will be congruent because I cut it down the middle, blah, blah, blah. You don't need to go through the last video, right? All you need to do is say by the isosceles theorem, and they'll know what you did. It's like a shortcut. It's a technique, right? It's a way to tell me what you're doing in a shorthand. So if I say justify your reasoning, that's all you got to do. Handy. If I don't say justify your reasoning, you don't got to worry about it at all, like if it's a worksheet on the isosceles theorem. Next one. Now, not all of them are going to be so straightforward, right? The last one, we just immediately were able to connect them. Some of them, though, are going to have some wrinkles, right? So this one, for example, I'm going to use the isosceles theorem, and I'm going to see this goes to here, and this goes to here. Notice I'm trying to solve for x, right? I didn't point to x at all. This is an x. Uh-oh, right? That's not that. It's something else. So what is it? Well, it's 70 degrees by the isosceles theorem, right? I still don't have x, you might be saying to me in a video, in which case maybe email me that, right? So if you're saying, I still don't have x, what the heck are we doing to find x? Remember, the three angles of a triangle add up to 180 degrees. I have two out of the three angles of a triangle. Anytime you know two of the three angles, right, and you need to find the last one, that's a simple application of the triangle sum theorem. So what I have going on now is I have 70 plus x equals 180, right? And you'll see, okay, can I solve for x? Yeah, right, I can find x now. I know that I have 140, and then I got x, so I just need to figure out what's left, right? And that's going to be x, it has to be 40 to make that equation true. I subtracted 140 from both sides, right? Your brain might have just gone, okay, what's 40 more than 140? It's 180, right? That's maybe how you did it, but in your brain, you're doing the subtraction if you don't realize it. So the answer would be x equals 40, not 70. A lot of people would jump to 70 here, but remember, it's only the opposite angles that are congruent. X is up in the tippy top. Whenever x is between the two congruent sides, it's not the one that's being doubled, right? It's not the one being compared to something else. It's only the base angles that are congruent with the isosceles theorem. All right. What if we get a little trickier, right? So this one, now I have this other addition of a 90-degree angle. So be careful. That does not mean that each of these angles is 90 degrees. It means that put together, they add up to 90 degrees. So whatever this top angle part is and this bottom angle part, they add it to 90. It could be 70-20. It could be 30-60. It could be 45-45. I don't know. All I know is that put together, they add up to 90. So what are we going to do to figure this out? Well, good inkling is usually to start with the isosceles theorem, right? Because one, this is a video called isosceles theorem practice, right? But two, I can see I have isosceles triangles. I got two congruent sides. So looking at what's opposite, I can see that 60 is going to be copied over here, right? Because it's congruent. And doing the same thing for this bottom triangle, opposite, opposite, that means I got two x's to work with. Now what? Well, I don't know much more, but I do have 2 out of the 3 angles in a triangle. And you'll remember we just said if I know 2 out of 3, I should find the third. So I'm going to do 60 plus 60 plus x equals 180. And I'm going to get x equals 60. How do I know that? Well, I subtracted 120 two 60s from both sides, right? When I do this, you'll see anytime I have a 60-degree angle in a isosceles triangle, they all are going to be 60 degrees. No matter where I put it, it works out that way. If this one had been 60 degrees, I would have known that these two had to be 60 because they would have had to be the same, and that's what's left, 120, right? All isosceles triangles that have a 60-degree angle end up being equilateral triangles because all equilateral triangles have 60-degree angles and nothing else. So equilateral triangles are a kind of isosceles triangle. Helpful to know. Now over here, I have, well, this is 60. I got the two x's, but I don't know what's this part, right? Actually, I do. Because if this part is 60, then like we said earlier, this part has to be what adds up to 90. And that is going to be 30 degrees. So now I can do another equation. 30 plus x plus x. Can I solve for x? Earlier I said if you know 2 out of 3 angles, right? But there's actually a little more to do there. If I know everything except one thing, do I know everything except one thing? Arguably, no, arguably, yes, right? There's two unknowns here, but they're the same unknown. I just need to figure out what x is. If I figure out what one x is, I figure out what both x's are. So really the equation here is 30 plus 2x, right? This is algebra now, and some people are good at algebra, some people struggle, but when I put them together, now I take away 30 from both. I get 2x equals 150, and that leaves me with x equals 75. So you can see here there were a lot more steps to get there. I had to do an entire second triangle in order to figure out my first triangle, right? Trickier. Now, the big takeaway here is that when I have two x's, that counts as one unknown. And whenever I have everything known except one thing, I'm good to go, right? But if we had had, like we did earlier, the x up in the tippy top and the 70 doubled, if I didn't know those two angles, I couldn't do it, right? I can't divide that in two willy-nilly because I don't know that they're going to be necessarily the same, right? That's the trick. All right, next one. This one also adds another thing that we need to remember. Vertical angles are congruent. So let's see how that's going to come in handy. Once again, I'm going to double. I'm going to use the isosceles theorem here, opposite, opposite. That gives me x. I'm going to use it here, opposite, opposite. That gives me that this is 55. And then I'm going to, again, just use what I know, right? And I'm going to be able to fill this in and say, okay, well, if these are both 55, that's going to be 110. What's left from 110 to get to 180? That is 70, right? Using the triangle sum theorem. Okay, if this is 70, I don't know what this tippy top is. I don't know what this is, right? That's not helpful yet. So how am I going to figure this out? Well, remember, vertical angles are congruent. You might need to review your notebook or a past video on what vertical angles are, right? What that means is when I see this formation, a crisscross intersection, right? Angles opposite the intersection are congruent to each other. So x is not just x, it's actually 70, right? By vertical angle, x equals 70. And we're done. So the key here was that I knew I needed to get this to the vertical angle in order to find congruence, right? So the x was able to be reflected over there through the isosceles theorem. I needed to figure out what this angle is, and I did that by filling it in by reflecting over here and then using the triangle sum theorem to get that, right? So lots of steps to get to that final conclusion. Okay, now the part that many people are probably waiting for. What is going on with these problems on the worksheet, right? What does this have to do with isosceles theorem? Because this isn't some isosceles triangles that we're applying to, is it? Well, yes and no. You don't need to use the isosceles theorem for this, right? What I'm trying to do is find x. I can find x without the isosceles theorem at all. I have a shared side in the middle, and remember, shared sides are congruent to themselves. So I have a side that's congruent to a side, an angle congruent to an angle, and then another side congruent to itself. So by side angle side, I know the triangles are congruent, right? And then by congruent triangles, right, I know corresponding parts of congruent triangles are congruent, CP, that means 8 equals x. So that's one way of doing it without using any isosceles theorem stuff at all. But the isosceles theorem allows you to use more tools here. For example, the isosceles theorem gives me, well, I have two sides that are congruent to each other, so opposite angles are also congruent to each other, right? And now I could use side, angle, side, or angle, side, angle. right? That's another option I could have used. Oh, interesting, right? So another set of tools available to me. I don't need to use the isosceles theorem here, but it makes these problems a little easier because it gives me even more things to work with, right? You might also remember, wait, if this is the isosceles theorem, we used a perpendicular bisector for that, right? Perpendicular bisector gives me another angle to work with, and it gives me another pair of congruent sides to work with. So now I know every single thing in this triangle is congruent to something in the other triangle. I don't even need to use CP/CDC or anything like that. I don't even use the postulates. I just know everything is congruent to everything, right? Lots of different things here that the isosceles theorem tells me. But the key thing is really, it's just actually a triangle postulate problem, triangle congruence postulate, right? The isosceles theorem just gives me more information to work with, but it doesn't change that this is a triangle congruence postulate problem. Cool. So this one's actually not as hard as it looks unless you're kind of bashing your head trying to figure out how it's like the other ones, right? All right. Hopefully that makes sense. If you have any questions about this or any of the parts of this activity, just email me. I'm happy to clarify and further explain, but I hope this makes sense and I hope this was helpful. I'll see you soon. Thank you.